Okay, let's unpack this. We are diving deep into Kyverno governance today.
We are. And if you're running Kubernetes, you know that trying to get a handle on policies, the who, what, and when of your resources can be, well, a huge headache.
Absolutely. And if you're looking to move your cloud environment from, let's say, chaotic to controlled, Kyverno is really the policy engine you need to master.
And to give you a perfect roadmap for that, we're actually using the structure of the Kyverno Certified Associate curriculum, the KCA exam.
Right. We're not making you sit for the test, but that curriculum, it's like a laser-focused blueprint. It tells you exactly where the most crucial technical knowledge is.
Our mission today is pretty simple. We want to give you a complete, high-level, but still technically precise understanding of Kyverno's architecture and, its essential capabilities.
Think of this as the fastest way to really get up to speed on Kubernetes governance.
And what's so important here is that Kyverno is much more than just a simple YAML parser. I mean, it fundamentally lets you enforce true policy as code.
Meaning, you can control the entire admission process dynamically.
Exactly. It's the difference between just having simple checks and having true, rigorous governance.
So, to structure our deep dive, we looked at the domains the KCA curriculum prioritizes. And the sources, they pretty much confirmed what we suspected.
Let me guess. Policy writing is at the top.
It's the undisputed focus, yeah? Takes up the biggest chunk of knowledge by far.
Which, makes perfect sense. All the other domains, fundamentals, installation, the CLI, they're all just infrastructure to support your policy writing.
Right. If you can craft a solid, secure, and smart policy, then you really understand Kyverno.
It's all about putting those rules into practice and making them stick.
But before we can write anything, we have to know where our policies are going to land. And that brings us to scope. So let's start with those governance fundamentals.
Agreed. The very first decision you make determines the scope. And that leads us to the crucial distinction between a standard policy and a cluster policy.
Okay, so walk us through the practical difference there. What's the impact of that scope?
A standard policy is what we call a namespaced resource. Its reach is limited. It only applies to resources inside one specific Kubernetes namespace.
So that's your tool for localized governance.
Exactly.
So like if I have Team Alpha running some legacy service that needs special exceptions, while Team Beta is running brand new serverless functions that need much tighter rules.
That's the perfect example. You use a policy to tailor enforcement just for Alpha's namespace without impacting the rest of the cluster.
And the other one, the cluster policy.
A cluster policy is, as the name suggests, cluster scoped. It applies universally to all namespaces. And it often targets those global resources like nodes or even namespaces themselves.
So that's your non-negotiable security baseline.
That's your security baseline.
Okay, that distinction makes sense. But let me push back a little. Why do we need Kyverno for this? Can't you do scoping with, say, RBAC or network policies?
That's a great question. So
Right.
RBAC controls access, who can do what. Network policies control traffic, who can talk to whom. Kyverno controls the content and the configuration of the resources themselves. So you might be allowed to create a deployment via RBAC, but Kyverno is what makes sure that deployment is configured securely.
So it checks for the right labels, a verified image, things like that.
Exactly. It's a layer deeper than just access control.
Okay, fantastic. So once we know where the rule applies, we need to figure out what happens if someone, breaks it. The sources highlighted the validation failure action field. How does that work?
This is where you set the strictness dial. And there are only two valid modes. They define whether Kyverno is acting as a gatekeeper or more of an observer.
Let's start with the gatekeeper, the strict one.
That would be enforce. If you set a policy to enforce, Kyverno becomes the digital bouncer. It rejects the non-compliant resource instantly at admission time.
So the API server just throws an error and it's blocked.
A hard block. The resource is never created. It guarantees compliance. But, that power comes with some serious responsibility.
Oh, I can imagine.
I've seen it happen. A missing label in an enforced policy brought development to a grinding halt for hours. You need to be very confident in that rule.
Which I assume leads us to the observer role. The other one, audit.
Audit is vital. This mode lets the resource be created, but Kyverno logs the violation. It just records the compliance failure for reporting without stopping operations.
So it's perfect for testing new policies.
For testing, for rolling out controls gradually, or just monitoring legacy systems without, causing an outage, it's the safe default.
That's a critical safety valve. But if it's audited, that violation data has to go somewhere. Where does the compliance data actually land?
Well, the reporting structure mirrors the scope we just talked about. If the policy is cluster scoped, applying to things like nodes or persistent
The
volumes,
global things.
right, global things, the results are stored in a cluster policy report. That's your big picture view.
So if I want to see the compliance of my entire infrastructure baseline, I check that report.
Correct. But for a standard namespace resource, like a deployment inside the billing namespace, it uses a standard policy report that's stored right inside that same namespace.
Ah, so the violation data lives right next to the resource it describes. That must make things a lot easier for any tools consuming this data.
It creates a really clean, structured audit trail that just follows the Kubernetes hierarchy.
Here's where it gets really interesting. We're moving beyond simple static chems now, into building genuinely intelligent policies with logic, conditions, and external data.
This is where the real power is.
So when a request comes in, what is Kyverno actually looking for in that admission request?
The policy uses its match glock to define selection criteria, and the sources confirm that the valid identity-based attributes it supports are service accounts and user groups.
So the policy can ask, is this request from the prod pipeline service account, or is this user a member of the security auditor group?
That's the fundamental link between access control and configuration control. But here's the big aha moment from the sources.
What's that?
Infrastructure-level data is explicitly not available in that context.
You mean things like which node the pod will land on, or, I don't know, the node's temperature?
Exactly. Or a hardware serial number. Kyverno operates at the API admission layer. It validates the YAML before it's written. It has no visibility into the underlying physical hardware, just the metadata in the API request.
That's a great line in the sand for engineers to understand. It governs resources, not hardware health.
Precisely.
Okay, let's talk conditional execution. If I have a really complex rule, how do I tell a policy, only run this validation if this other condition is true?
You do that with preconditions. Preconditions are evaluated before the main validation or mutation logic ever runs. They're the initial filter.
And why do you need that? Why not just put all the logic into the main rule?
Because it lets you create highly context-aware rules that are far less brittle. Instead of one giant nested rule, you can have 5 simple rules, each gated by a precondition.
Like, only check for GPU requests if the resource is in the AI workload namespace.
That's a perfect example. So instead of one huge, fragile policy, you get flexible, targeted enforcement. It makes debugging so much simpler.
Absolutely. And speaking of flexibility, Kyverno isn't just stuck with the data in the admission request, right?
Not at all. This is where we break out of static rules entirely. You can incorporate external runtime data.
So the policy can actually reach out and grab information from somewhere else.
Yes. And that capability is enabled by context variables. They let Kyverno retrieve and reference external data during an evaluation, like from a config map or even an external API.
Wow, that is powerful. So instead of hard-coding a list of approved container registries in my policy, I could just pull that list from a central config map.
And the security team manages that config map. The policy becomes dynamic. It could pull the minimum required security patch level from a config map that updates every hour.
But if you're pulling data from these complex Kubernetes objects, which are just, giant nested JSON structures, you need a way to query them reliably.
You do. And for that, Kyverno relies on Jamie's Path. It's a query language specifically designed for JSON.
I've seen Jamie's Path in other cloud tools. It's pretty standard.
It is, and that's a good thing. It lets you precisely extract specific fields. I mean, if you need to find an environment variable that's the third item in an array, nested 5 layers deep, a simple dot notation isn't going to cut it.
Jamie's Path gives you the tools to handle that complexity.
It's the language of data extraction for this ecosystem. It turns that raw, unwieldy YAML into actionable data points that your preconditions and context variables can use.
Okay, let's zoom out now to the really transformative stuff. Security and automation. Supply chain security is, it's non-negotiable today. How does Kyverno make sure the container images we're pulling haven't been tampered with?
This is one of his biggest selling points. It integrates directly with a specialized external tool for this, Cosign.
Cosign, part of the 6-store project. That's a huge deal for software transparency.
A very big deal. Kyverno leverages Cosign's cryptographic signing. So during admission, before an image is allowed to run, Kyverno can check that it has a valid signature from a trusted key.
So we're moving away from just trusting an image tag, which can be easily changed, to trusting an actual cryptographic signature.
It's essential. If the image isn't signed by one of your approved keys, Kyverno can either block the deployment in enforce mode or at the very least raise a critical alert in audit mode.
It closes a major vulnerability gap.
It really does.
Okay, that's a critical security feature. Now, let's talk automation for the engineers. You've got all these different workload types, pods, deployments, daemon sets. If I write a strong policy for a pod, do I have to copy and paste that rule for every controller?
Fortunately, no. That would be a nightmare for configuration drift. Kyverno solves this with a feature called Autogen.
Automatic rule generation. So if I write a policy that says all pods must have a specific security context, Autogen just handles the rest.
It does. If you write a policy that targets pods, Kyverno automatically generates the equivalent rules for the high-level controllers that manage them, specifically daemon sets and deployments.
Wow. So that ensures the rules are consistently enforced without manual duplication.
And that's a huge time saver. Engineers focus on the policy intent, and Kyverno handles mapping it to the right abstractions. It prevents that classic drift problem where someone updates a daemon set but forgets the pod security rule.
Exactly. Okay, one last thing. We've talked a lot about admission control creation, modification, but what about lifecycle management? What about cleanup?
That's where the cleanup policy type comes in. It's designed specifically to automatically delete Kubernetes resources when certain conditions are met.
So it moves governance from just saying no at the door to managing the whole lifecycle.
It does. The most common use case is setting a time to live, a TTL. You can automatically clean up temporary test namespaces after 48 hours or delete stale persistent volumes after 90 days.
It's just good cluster hygiene.
It is. It lets you encode the cleanup process right alongside the creation rules, making sure resources are managed responsibly their whole life. It's governance moving into automatic remediation. So here's a thought to leave you with. Given all this, you should explore just how far you can push a cleanup policy to automate compliance remediation without any human intervention at all.
That intersection of policy and automatic action.
That's the next frontier of governance.